Hi everyone. Okay, now let's see how we can solve this electric field question. Now we have now the question read calculate the intensity of the electric field in volts per meter, which would produce in an electron an acceleration equal to that due to gravity. Okay, so now in this case, we want to calculate the intensity of the electric field in which the electron, okay, exists, okay, when a force acts on the electron to give it an acceleration which is equal to acceleration due to gravity. Okay, so let's have our solution. So in this case, okay, we have we know that the mass of electron, which is me, okay, the magnitude of the mass of electron is 9.1 times 10 raised to the power of minus 31 kilograms. Okay, now we also know that because electron is a negatively charged particle, okay, so the charge on electron is negative E, and the magnitude of the charge on electron will be negative 1.602 times 10 raised to the power of minus 19 coulombs. Okay, minus 19 coulombs. All right. Now we have we want to find the intensity of the electric field, okay, which would produce in an electron an acceleration equal to that due to gravity. So that means that when a force acts on the charge which exists in the what electric field, okay, now the force would develop an acceleration on the charge, and the acceleration, okay, given to the electric charge will be equals to acceleration due to gravity. So which means acceleration, we have the acceleration due to gravity, okay, acceleration due to gravity. So for acceleration due to gravity, we have that to be what? G, and that is what? We are using 9.81, okay, 9.81 meters per second square. That is the that's the magnitude of acceleration due to gravity. All right, so we want to calculate the electric field intensity, and we know that electric field intensity, okay, can be expressed as the ratio of force acting on the electronic charge, okay, per unit coulomb of the what electronic charge, which means force acting per unit coulomb of an electric charge is what we call electric field intensity. So we have our electric field intensity, okay, electric field intensity, also known as electric field strength, okay, that is the unknown, parameter. Okay, now to be able to calculate the electric field intensity, now we know that now we have mass of electron. Okay, now when a force acts on the electron, okay, of mass 9.1 times 10 raised to the power of minus 31 kilogram, the force will develop an acceleration. So which means now we know that the force, okay, the force the force the force due to charge E, okay, in the electric field in the electric field in the electric field of field intensity E, okay, would be F equals to QE. Okay, that is, now here I represent Q, that is E is represented as what? As Q. So the force due to charge E in the electric field of field intensity E is what? F equals to QE. You know, the charge exists in the what? Electric field, and the charge experience an electric force. So when the force acts on the charge, then the force accelerates the charge. So in that case, we are going to what? We are going to apply Newton's law of motion. That is Newton's second law of motion. So in this case, we know that from from Newton's law, we know that F is equals to ma. Now, don't forget that the acceleration of the electric charge, that is the accelerated electron, is what? Is the same as acceleration due to gravity. So we are going to equate this. We are going to write m mass of electron multiplied by acceleration due to gravity, and that equals to E, which is the charge on the electron, multiplied by what? Multiplied by the electric field intensity. All right, now let's express electric field intensity in terms of other quantities. So we have ME multiplied by G, okay, over what? The electronic charge. Now, don't forget I said the electronic charge is what? Negative. So which means the magnitude of the electron will be what? Negative 1.602 times 10 raised to the power of minus 19 coulomb. So the electric field intensity will then be 9.1 times 10 raised to the power of minus 31 multiplied by 9.81, which is the acceleration due to gravity, then over 1.602 times 10 raised to the power of what? Minus 19 coulombs. Okay, now the unit of electric field intensity will be what? Volts per meters. Okay, now so this will be negative. Now let's get the value. Let's multiply 9.1 by 9.81. Okay, so what is 9.1 multiplied by 9.81? So we're going to get 89.271. Okay, then we multiply that by what? Negative 31 over negative 1.602 times 10 raised to the power of what? Minus 19. And this is in what? Volt per meters. That is the unit of electric field intensity. Okay, so in this case, now let's divide 89.271. Okay, let's divide it by 1.602, which is which will be what? 55. So we have the electric field intensity to be 55.74. Okay, 745 multiplied by, so that will be negative 55.745, okay, times 10 raised to the power of negative 31. Okay, so we're going to add 19 to 31. Okay, so when we combine the powers of 10, we had 19 to what? 31. So that now the unit is what? Volts per meters. Okay. So what is minus 31? Okay, plus 19. Okay, that will be negative 12. So this will be negative 55.745 multiplied by 10 raised to the power of what? Minus 12 volts per meter. And this is the electric field intensity. Now, this is not, we are going to what? We are going to get a final answer in this case. All right, so, but what is important here is that now we have the magnitude of the electric field intensity to be negative. Now, this tells us that the electric field intensity is directed in a what? In an opposite direction to the what? To the acceleration due to gravity, because we know that whenever a body exists in the earth's gravitational field, for instance, we know that the effect of gravity is that gravity will always act downward on a body. Okay, because when force of gravity acts on any object, okay, existing in the world gravitational field, the gravitational force will develop an acceleration on the object. Okay, so the acceleration will not be what? It will not be called acceleration due to gravity. So the same thing happens in this case. We have the electronic charge which exists, okay, in an electric field. So the electric field intensity, okay, the electric field intensity is moving in a direction, okay, opposite to that of what? Acceleration due to gravity. Okay, the acceleration due to gravity will move downward, okay, while the direction of the electric field intensity will be opposite to that of what? Acceleration due to gravity, and that's why it is negative. Okay, now we can neglect the negative sign since we are looking for the positive value of our electric field intensity. So the electric field intensity, okay, now let's move the decimal point. This will be 5.5745, okay, times 10 raised to the power of 1 okay, then multiply by 10 raised to the power of 12 volts per meters, okay, so that the electric field intensity will be 5.57, okay, 7575 times 10 raised to the power of 1 minus 12, that will be minus 11, and this will be in volts per meters. So this is the magnitude of the electric field intensity, okay, which will produce in an electron an acceleration equal to that due to what? Due to gravity. Now, don't forget that now the unit of we can have the unit of electric field intensity to be Newton per coulomb or volt per meter, because now note 1 Newton per coulomb, okay, 1 Newton per coulomb is the same thing as what? 1 volt per meter. 1 Newton per coulomb is the same thing as 1 volt per meter. So is if the unit is supposed to be Newton per coulomb, we can also write the unit as what? Volt in volts per meters, because 1 Newton per coulomb is equals to 1 volt per meter. And we know that electric field intensity is the ratio of force acting on the electron to the what? To the charge, okay, on the electron, okay, which exists, the electron exists in what? In an electric field. The noblest pleasure is the joy of understanding. Bye bye.